Okay, suppose the task is just finding the intervals in which this function is increasing or decreasing. Even if the question was changed, the process or the steps that you will be doing are just the same. So first, we need to establish the first derivative. This will be our key in determining the intervals. The first derivative is 4x cubed minus 16x. And always remember that the derivative tells us the slope. Is it positive? Is it 0? Is it negative? A positive slope means increasing. A 0 means it's a horizontal tangent line. And then when it is a negative slope, it means decreasing. So meaning to say, if we are asked to find the intervals in which the function is increasing or decreasing, all we have to do is to check when is the derivative greater than 0 in this case. And in this one, when is the derivative less than 0? That's all we need to establish. F prime of x greater than 0, f prime of x less than 0, increasing and decreasing respectively. So using our example, f prime of x is equal to 4x cubed minus 16x as the derivative. We first find the critical points because the critical values, because at those values we will be changing maybe from positive to negative or negative to positive, or sometimes no changes at all. Okay, so we set this to 0, and 4x cubed minus 16x is equal to 0 means 4x, x squared minus 4. So the possible x are 0, negative 2, and positive 2, which is what we solved already in the previous example. X is 0, negative 2, and 2. Okay, to ease the finding of the intervals, we still remember the table of signs. Okay, it will be, to make the process shorter, we have 0, negative 2, and 2. Sometimes assigning numbers and testing numbers will take us some time. Like you substitute and then you check what is happening in between those intervals. So what we could do to simplify the process is by making use of the table of signs. Okay, and now I will illustrate how to do it. So x squared minus 4, by the way, is x minus 2 and x plus 2. You list down all the factors of the derivatives of the derivative 4x, x minus 2, and x plus 2. And in each factor, okay, you have to determine what is happening before and after each number. Okay, now this is how we simplify the process. Remember that 4x will be 0 at 0. X minus 2 will be 0 at 2. And x plus 2 will be 0 at negative 2. For each factor, they have a specific turning point or turning value. 4x will change at 0. So we mark, okay, it is 0 at x equals 0, right? X minus 2 is 0 at x equals 2, and 0 after at negative 2 for x plus 2. In each case, determine what is happening before and after 0. Focus on 4x. What is 4x when x is before 0? Negative. So all those intervals will get negative. But after 0, positive. For x minus 2, negative, 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 and then positive. And this one is negative, positive, positive, and positive. And then conclude by working on the signs. This is 4x times x minus 2 times x plus 2. First interval is negative. Follow? Did you understand? Second interval is positive, because negative times negative is positive times positive is positive. This is negative, and the last one is positive. So this is where you get your conclusion. That negative sign that you see here means it is decreasing. The function here is increasing, decreasing, and then increasing. So parang decrease, increase, decrease, and then increase. And you can clearly see your maximum and minimum points. Diba? It's connected to the concept earlier. But since we are just looking for the intervals and if the function is increasing or decreasing, then give me the intervals and decreasing, how to write it properly. From negative infinity up to negative 2, open. Union, meaning to say 0 up to positive 2. Understood? Increasing from negative 2 to 0, union 2 to positive infinity. We're not looking for any maximum or minimum point. It is just increasing or decreasing interval. Okay, I think we can cut it there. We'll have the other questions, points of inflection and concavity next time. So that means concavity and points of inflection will not be part of your short quiz. Okay?